Oh, Gavin, don't be dramatic. This will take a while. Tomorrow is going to be primarily a work day, and on the front end of work days is usually a lot of notes. So this is going to feel like an Algebra 1 lesson for about the first 10 minutes. And then the reason I have to do this part of it is to make sure that you're ready for the Algebra 2 part of it. So yeah, let me make sure. Did I actually hit record, I wonder? I did. Nice. Yeah. So today's the 28th. Yeah, we'll be at December so soon. It's nuts. I can't even believe it. And what you're going to be doing is solving what we call 3x3 systems. And the term 3x3 is like an informal sort of casual way of saying that we'll be solving systems of equations where there are 3 equations and there will be 3 variables. So I will use X, Y, and Z when I do my notes, but in your assignment, you might see different variables, just for the record. So if that comes up, don't panic. It's the same old, just again, the letters can change, but that's irrelevant. So generally, if you do see different letters, you want to alphabetize them. So like if you see A, B, and C, make sure you solve them as an ordered triple of A, then B, then C, or like R, S, T, something like that. But I think X's and Y's and Z's are what you'll see a lot of. So anyhow, before we can solve 3x3 systems, I have to do a quick review and make sure that you remember, because I was your algebra teacher. So if you don't remember this is my bad. You got to know how to solve 2x2 systems first. And so this is something we learned back in Algebra 1. So I'm going to start you. I have 4 levels of these that I'm going to run through. Nothing that's about to happen should look new at all. And these will go in a very particular order of difficulty, level 1 up to level 4. And at no point will they ever actually achieve anything that resembles difficult. They just are not as easy. So this is a system of equations. And in this particular case, what it is it's a pair of lines. And if we were to graph those lines, then they would cross at some point in the coordinate plane. And our mission is to figure out where do they cross. And we're not going to graph or anything like that. You'll remember from last year or 2 years ago for some of you that we solved systems by graphing, which we're not going to do, by substitution, which we're not going to do, and by elimination, which we are going to do. That's all you'll be doing for the next at least couple, maybe 3 days is elimination. And elimination is the method where you add the equations together downwards and hopefully a variable cancels itself out. It's where the word, it comes from, elimination. We're eliminating a variable. So I started you with this problem because it just math almost doesn't get any easier than what we're about to do. So if you add these equations together, would something cancel? Yes, the y's will. So this is good. That means we're ready to proceed. So when you add straight downwards, you get 13x's. Do you agree? And we also agree that the y's eliminate. And then we copy down our equal sign. And what's 24 plus negative 24? Good. And then you just have a little 5th, 6th, 7th grade equation to solve. If you divide both sides of that by 13, you figure out that x equals 0. And that means that the answer to our problem is 0, comma something. And as always is the case in algebra, if we know one half of an answer, how do we find the other? You plug it back in and you can pick any of the equations that you like. I don't think you're going to get much resistance from either of them. You'll get the same answer. So let's say that we take our 0 and we plug it right there. You can't miss where that arrow is pointing. What would that say? 5 times 0 is 0. So the equation would actually say negative 4y equals 24. And then when you divide by negative 4, what's y? Negative 6. And so the answer is the point 0, negative 6. The upshot there, what that means is if we were to have manipulated those lines, equations, and graphed them, they would cross at the point 0, negative 6. Got it? Okay, let's scale the difficulty up just a tiny little skosh here. So if we were to add the equations together, would anything eliminate? They would not, right? And so I tried, if you do this job long enough and you just try stuff and then you kind of learn what works and what doesn't work. So I have dabbled with having students subtract the equations from each other. And after a few years of diving in there, I realized it's best if we just always make opposites and add. I'm settled on that. And so I look at the x's, and yes, I could do x minus x, but then I run into some basic skills issues with minuses and no. So what I'm going to do is I'm going to say, you x's, you're pretty close to being cancelable, but I wish that one of you were a negative. So I'm going to take, say, like the top equation and multiply it by -1. I hope this is coming back to you. You can multiply either or both equations by anything that you want to. So the new top equation would say negative x, and then what? Plus 7y equals positive 5. And then I copy down the old bottom equation, the one that I didn't have to modify. And I get this. And now it's a self-eliminating system. We made it that way, I guess. So now when we add together, the x's obviously eliminate. How many y's do we get? So we get negative 3y. And what's 5 plus -8? And if we divide by -3, we get y equals positive 1. And so again, the final answer, I say final, I mean, I do this on purpose. It's up there in the corner of the television, and all that's missing now is the other half. And again, if you know half, you plug it in to find the other half. And you can pick any of the three equations. And I say three now because there's like original equation 1, modified equation 1, and original equation 2. So I mean, you could go wherever you want to. You're going to get the same answer. That's how this works. So which equation seems the most attractive to you? Original number 2. So that's this guy here. So if we change his y into 1, this original second equation would now say x minus 10 times 1 is 10 equals -8. Add 10 to both sides, x equals, well, 2. And so then we can say we did it. That means those lines would cross at the point 2, 1. Should feel like a review to you. All right. Let's scale the difficulty up just a little bit more now. And so for this one, you probably know where this is headed. We have negative 9x plus 2y equals -1. And our second equation is going to be 8x minus 6y equals 22. This is totally algebra 1. Yeah, you did this a couple of years ago, Gavin. Yeah, you and Chris, remember? Yeah. We don't want to talk about that. Right. And so I chose this one because I don't want you to feel like you have to change the 9s and the 8s both into 72s. Look always for the path of least resistance. And you say to yourself, look at that 2 right there. Oh, how I wish that it were a 6. And if it were, then it would cancel with the 6, the -6 below it. And so we're simply, path of least resistance here is always just multiply one equation if you can. Less work. So what's the new top equation? Nice job. And the bottom equation does not change. So we'll just leave it, copy it over, 8x minus 6y equals 22. And then we're good to go. It's now eliminatable. I don't know if that's a word, but it should be. So when you okay, Gavin? This 3, because I knew that I wanted to turn this 2 into a 6 to cancel with the -6 that's below it. So we multiplied by 3. Whatever you want something to be, just make it be. Yeah, what do we get?
It's not. Let's say that we divided.
Yes, I knew exactly where you were going, and I just wanted to, out of courtesy, let you finish. You may divide equations in the same way that you multiply them. So yes, if you could divide all of one equation to bring it down to be common, of course you could do that as well. Bottom line is just make a match, make them opposites, add them together. So now when I add these red and white ones over here, how many x's do I get? I get negative 19 x's, and then the y's cancel, equals what? Negative 3 plus 22 is positive 19. Divide both sides by negative 19, and you get x equals negative 1. And again, the answer then, I'll put it up here in the corner, is negative 1, comma, who the heck knows? And the who the heck knows gets solved by putting the half that we know back in into any equation that floats your boat. I'm feeling kind of good vibes with this. I'm going to circle it in green. I really like that one that I circled in green. So I'm going to go with that. Yeah, totally. You can pick any. That one feels nice to me. And that'll be different for each of us, you know? It's okay. So if I go to this equation now and I change his x into negative 1, 8 times negative 1 is negative 8. So I have negative 8 minus 6y equals 22. I add 8 to both sides. I get negative 6y equals 30. I divide by negative 6, and I get y equals negative 5. And then I can go up here now and complete the riddle. You know what I mean? Is this feeling good? Okay. Last one, and then we'll bump up into the Algebra 2 portion of the lesson. This one, you know exactly where I'm headed with this, I'm guessing. So we notice right away that it's certainly not a cheesecake problem. Like, we know that we can't just add, and it's even worse because, like, I can't turn any one number into something that will match another number, not without using fractions. And we certainly don't want to go down that road. So at this point, we're going to have to multiply both equations. And you have to just choose, would you rather manipulate the 7 and the 9? What would they both turn into? 63. You could make them both into 63s, or alternatively, what would the 3 and the 5 both become? Yeah. Right. And so as long as we understand our mission that we need to make opposites, that's the bottom line. Don't turn them both into 15s. Turn them one into 15, one into negative 15. So I'm going to go with what I heard Alyssa say first, and that is, let's take the top equation and let's multiply it by negative 5. With the objective being that, hey, 3, you got a target on your back. I'm going to turn you into a negative 15. And then the bottom equation, I can just multiply him by normal 3. Don't do them both by negatives. That'd be downright stupid, right? So now what's my new top equation going to say? You're right. Yep. Good job. And then the bottom equation, if we triple everything, what do we get? Nice. Good, good, good. And so now we've created an eliminatable system. By doing what we did, we've made it now so that the y's will eliminate. And so now when we add the equations together, how many x's do we get? Positive 8. So we have 8 x's equal to, what's negative 85 plus 69? Not 16. Definitely negative 16. And I will just caution you, the road that we're going down here today, starting in about 1 minute, every little mistake will make you so angry. Me, kind of. You, very angry, because these problems will take time. And one missed negative, one little time of saying 3 times 3 is 6, gone. 7 minutes of your life, 8 minutes just gone. So try to be, I mean, we're human, but try to be as tight as you can be. Divide both sides by 8 and you get x equals negative 2. And so that tells us that our answer looks like this, negative 2, comma, something. No one cares what we solve for first. Like, that was our choice, right? And then which equation is feeling most peaceful to you? Okay, this one here. No problem. I would have probably picked the original number 1, smaller numbers, but I'm going to go with what you guys said. So if we take that equation and we change his x into negative 2, it'll say 18 plus 5y equals 23. And then you subtract, get 5y equals 5, divide, you get y equals 1, complete the puzzle, boom, jackpot, done. That is not what we're doing today, but I should get your brains going back into that mode. Any questions about that? Okay. Good. So what you are doing today are triples. 3x3s. So I would caution you, and I'll be very careful also. Make sure as you copy these down. Hello. I don't know. Thank you. Good job. I love it. Defeat. I was going to say 4 foot. It's kind of on the right track. Thanks. Just like I did with the first Algebra 1 part of today's lesson, I'm scaffolding these up in order of difficulty for Z, my cross my Z's. So you'll always know when I do a Z because I cross it. This can be a massively tidy, tight, clean process if you're willing to let it be. I can tell you as we go now into the next few days that if you're a chaotic sort of person, then you and I are going to have some issues because for every problem on a quiz that you do, I have to read it like a book. And so I'm going to give you some guidelines and some pointers as to how to communicate with me on writing, like on paper, how you're doing or why, like what are you doing? How did you get that? It's a real clean way to do this. So the reason I gave this to you as a warm-up problem is because if you look at the third column, you should be able to spot that all those Z's are just waving a flag at you. Like, just look at us. We're ready to cancel out. And so step one, when we do this, is pick a variable. It could be looking at you crossways, or it can just be easily eliminatable, and you're going to kill that variable twice. So we're going to basically do the first step twice, and I'll show you why, or you'll figure it out for yourself. But take a look at these 3 equations. We're going to refer to them as R1. I got to remember to switch back to my pen. This is R1, this is R2, and this is R3. Those little subscripts are just labels. They're ways for us to say first row, second row, third row. And that's what we're going to name them so that when we write things down, we can tell somebody what it is that we're doing. So someone doesn't have to try to read our minds. So if you think about this, if you were to take row 1 and row 2 and add them together, or row 1 and row 3 and add them together, something good would happen, huh? Do you see that? So we can pick, and honestly, this one's going to be a little easier than even I thought it was going to be, but that's okay. So when we add, let's say we do row 1 and row 2, and if you're wondering why we would do that, it's because of this. Right? I don't care about anything else. And you could look at the Y's, but honestly, the Y's only eliminate once. The Z's are delicious and tasty in this problem because they'll die twice. So remember, you have to pick the same variable and kill it twice. Got it? Gavin, you with me? Twice. Nice. Are you looking strange because I said delicious and tasty? All right, then. So this is how we define a row operation. For whoever is reading our paper, we're going to put a little R1 plus R2, and then a little arrow. Do not put an equals sign, put a little arrow. An equals sign will be out of place. So this is my way of telling someone, hey, I'm about to add row 1 or row 2, and at the end of this arrow is going to be the result of that operation. So when we add row 1 and row 2 together, how many X's do we get? We get -6 of them. How many Y's do we get? None. Very good. And that's a very rare thing. I didn't anticipate this. I probably should have caught it, but this is going to be a super easy one. So not only do the Z's as intended cancel, but the Y's will also cancel. And I'm not going to do a lot of vandalizing in here because I need this workspace for what I have to do yet. So the Y's are going to cancel and the Z's are going to cancel, and I'm going to put equals. And then what's right here, -14 plus 16. Very good. Now we have to do this again, okay? So we have to kill the Z's one more time. Muy importante. So normally I would just say, let's just dive right in and solve that, but we'll come back to that in a little bit. We'll leave that kind of like a little treat there, okay? The other place where we can get elimination of z's is the operation of row 1 plus row 3. I hope you agree with that. If I do row 1 plus row 3, my inspiration, I'll put little red circles around them for you, is that this is in row 1 and this is in row 3, and they all cancel, right? So if we do row 1 plus row 3, what do we get? How many x's do we get? None. How many y's do we get? Good. And z's go away, and that equals negative 14 plus 19 is 5. And I say this is a very unique situation. If you come across one of these, it's like cha-ching. These problems normally take 7, 8, 10 minutes. These will take you 2-ish. What's nice is now I've just got these dumb little situations over here. Like, look at this equation with the red arrow pointing to it. That's a little 6th grade baby equation. Divide both sides by -6. What's x? -2. Okay, how about this one with the little green arrow pointing to it? Divide by 5. Y equals 1. So here's the upshot. Here's what we what does this mean? Well, it means that the final answer looks like this. Oops, I didn't want to do green. Okay, so the final answer looks like this. -2 goes in place of x. That's alphabetically first. The 1 goes in place of y. And you've probably never seen one of these before, but it's called an ordered triple. And it's got spots for all three-dimensional coordinates, x-axis, y-axis, z-axis. X-axis and y-axis are the two that kind of like face you. They're flat. And then the z-axis comes towards you in the third dimension. Yeah, if you look at like in Minecraft and you see like your X, Y, Z, that's what's going on there. Okay. And so how are we going to find the Z? Plug the 2 that you know back in. And so I could take, say, I like this. Let's do the second equation. I'll put a green box around this. I like this equation. You don't have to, but I do. So I'm going to take that equation. And the question I got earlier, yeah, was will it work no matter what I pick? Yeah, it will. It's all good. So if I take that green boxed equation down here and I change its x into -2, it'll say 4. And then if I change his y into 1, it says -2. And then plus 4z, bless you, equals 26. And on the left side, I'm going to do some basic algebra here. 4 minus 2 is 2. Subtract the 2 from both sides, and you get 4z equals 24. Divide both sides by 4, and z equals. So we just figured out that in the three-dimensional graphing in space, if you went left 2, up 1, and then away from yourself 6, then you would have your point. Yes, sir?
So in the first step, will we always get to the variable?
You will certainly not, no. And that was why I say that was a bit of an oversight. Let's do another one. You mean like how we tried to kill one and the other kind of died with it? No, that was a one-time thing. You'll see. All right, one down, a couple to go. So here we go. Next one. Again, please be careful as you write these down. I'll read out loud as I write so you don't have to wonder. -6x plus 4y minus 6z equals 12. And then the second row is -x minus 3y plus 5z equals 0. And then the third row is -4x plus 5y. Fix that real quick. There we go. Minus 5z equals -2. So the difficulty has ramped up just a little bit. Do you see something already different between this and the first one? There's only one cancellation that's ready, and I'm sure you spotted it. It's down there in that lower right-hand corner with the z's. Not trying to send some message that we're going to pick on z's. We're going to pick on whatever presents itself as wanting to be picked on. And so my focus is I'm going to take whatever I can get, and I have now said z's, you're going down. And so we have to make this happen twice. And so I'm going to do, you don't have to label these, by the way, every time. Like you don't have to label them as R1, R2, R3. I'll know what you mean when you give me a row operation, but just remember that that's who they are. So the first thing that we want to do is just take a freebie here. We want to do which two rows? Right, so we're going to show out of courtesy to the reader of our work that we're about to do this operation, row 2 plus row 3 with a little arrow. And then the results of that row operation, I'll put after the arrow. How many X's will we get? Very good. So that's the freebie. Now I have to kill Z's again, and you have a choice to make. I have an opinion, and I'll of course give it to you, but you have to kill Z's again, and you obviously can't use the same rows again. That would be dumb. So you may use a combination of row 1 and row 3, or you may use a combination of row 1 and row 2. I like 1 and 2 infinitely more because they're already set as one of them is a negative and one of them is a positive. So if I'm targeting the Z's, I'm attracted to these, not because they're cancelable right now, but because I won't have to manipulate signs, which is nice. So what can I turn those both into? What can I turn 6s and 5s both into? 30s, right. And so what I want to do now is I want to go down, and with that, this step is hard. Teenagers don't like to show this step because it takes more time, but it's still worth it. We're going to go down to the bottom and we're going to manipulate these rows. So down here, we're going to do 5 times row 1, and we're going to do 6 times row 2. It's worth it to show these and not try to do this next step in your head. I want to turn them both into 30s, and they're already opposite signs. And so I'm just going to see what would I get if I do this. And so my top row is row 1. If I take it times 5, what do I get? And then the row 2, if I manipulate it times 6, what would I get? Very good. Equals 0, I believe, right? And I mean, if you get done with this, this is almost like a little side project. It's kind of lame. I hate to ask you this, but it really does help. This little side project, if you look at your side project and nothing cancels, then you have to ask yourself, well, why in the world did I do that? What a stupid thing to do. And mission accomplished. We now have it so that when I add my manipulated rows together, I get what I want. And so up here where I've been doing row operations, I'm going to write 5R1 plus 6R2 with my little arrow. Being very mindful of the fact that somebody has to read my work. So I'm showing you down below, hey, here's my manipulated rows. And then up here, I'm going to combine them to get what I want. So when we add our manipulated rows down below together, how many X's do we get? We get negative 36 of them. Very good. Negative 36 X's. How many Y's do we get? Nice. And what is our constant term going to be? Very good. So you now would realize why I started class the way that I did today. Not only because we wanted to be freshened up, but what you see now in the upper right-hand corner of the TV is just an Algebra 1 problem. You now have to solve a 2x2. You just gutted a 3x3 and chopped it down to a 2x2, which we know how to solve. So when I talk about, let me put a big yellow box around it. When you talk about this system right here, who's the easiest variable to eliminate? Obviously the 2's. They're not ready to eliminate, so what should I do? Yeah, and multiply either of them by a -1, and you can just do this like up above to save space. So let's say we take this top equation by -1. His new name is 5x minus 2y equals +2. And then I can put just a light little strike through this equation because that's the one that I have now modified. So now you got your new floaty equation up on top and your white equation on bottom. Add those together. How many x's do you get? How many y's do you get? None, of course. And then what's 2 plus 60? Divide both sides by negative 31. What's x? Okay, great. We have a third of the puzzle done. I always say at this point in this lesson that we have only 1/3 of the answer, but we've done like 2/3 of the work. Because now, as we scaffold our way back up to find the other guys, it gets easy, assuming you're not completely lost. So if x is -2, per Gavin's advice, I can now write my final answer in yellow, and I'll say, okay, here it is. I'll put it down here in the corner. It is -2, comma, blank, comma, blank. There it is, ready to go. I never know who's going to answer this question right, so here it goes. It might be you. You're having a great year. Don't sell yourself short. Which variable do we have to find next? You have to find y. You have to find y. I know people are saying funny things, but you have to come back now and listen. You have to find y because you must now go up into this 2x2 system up here. You see that? You don't have enough information to find z because z is hidden in a 3-variable equation, and I don't know 2 of them to plug in, but I can go back into a 2x2. So when you think about the 2x2, the equations that only have x and one other thing, they're all pasted up there in the upper right-hand corner. Which one do you like the best? Probably the red one. I hope you agree. So let's take that red one and let's turn his x into -2. I'll put a little green star next to it. We're using this equation up here with the green stars, and I'm going to change his x into -2. So what's 5 times -2? So I have -10 minus 2y equals 2. Add your 10 across, you get -2y equals 12. Divide by -2, you get y equals, and I can now add a second piece to my solution. And finally, now, how will I solve for z? Use any of your triples. Any of these that I'm bracketing over here on the left will now work. Storm the castle at this point. You're like, okay, I'm armed and ready. I got an x, I got a y, and I'm coming to find z. And you get to pick any now of the 5. Sometimes you'll have 6 of them laying around. You get to pick any of them that you like. I am attracted to this one with the blue box around it. And since I'm the guy with the fake pen, I'm going to pick that one. You can pick any of them. It's all good. So if we take that equation with the blue box around it, it's hard for me on a limited screen to try to fit everything in here. I'm going to erase a little bit of work down here. So if I take that equation with the blue box around it and I change his x and y into numbers, what would -x say? And what would -3y say? +18. And then again, a little bit of basic algebra. Combine your 2 and your 18, you get 20. Subtract it to the other side, you get -20. Divide, you get z equals, and then you complete the puzzle and you're done. I'm going to show you a different strategy for this next example that I think you'll like. I didn't used to teach it this way, and starting a couple of years ago, with conversation with students, I figured out this next method is a little bit cleaner. I think you'll like it. Are you super lost? Do you need a minute to stretch? Send a tweet. Go do a Be Real, get caught up with all your homies, whatever. Let me pause the recording for 30 seconds and you can send a dank Insta tweet or whatever. This is example number 3, and you'll like this method. We could have used it on the last one, and I just choose not to show it to you until now. So if you don't like this method, then I've got nothing today that you'll even remotely enjoy. -2x minus 6y minus 4z equals -14. Second row is -x minus 3y minus 6z equals -27. negative 4x minus 2y plus z equals negative 3.
That's six or negative.
It is. I'm guessing as you look at this, you'll notice that we've sort of reached, I mean, the top of the mountain is when we start involving fractions. And we're not going to, don't worry, we're not going down that road yet. But the top of the mountain is when you start having uncooperative numbers. But this is getting close now because there's nothing on the house. Like, I dare you, find me one thing that cancels with something else that isn't there. And so what we want to do at this point is we're going to just, I call this the brute force method. We're going to pick a row that's looking at us kind of cross-eyed, giving us the stinky face. And we're going to redo the whole system. It's annoying in that it takes a little time, but it's so slick. So which row to you feels peaceful and simple to kill? The second one is a great answer because you could turn everything into sixes. And the first one would have been a great answer because you can turn everything into fours. And even the last one is a fine answer. You can turn everything into 12s. So collectively, the first one I hear is what I'll choose. Who are we going to kill? Middle one it is. So we have elected that we're going to murder off all of the y's. Good. So you got to know some basic like fifth grade math for this. What is the number that all of the rows, all the numbers in the middle column can be turned into? 6. So I look at it like this. And I'll make some notes over here off to the side. If I just leave this one be, then he'll have a negative 6, right? What do we want this negative 3 to become? A positive 6. So what will we multiply by? So we'll multiply that entire row by negative 2. What do we want this negative 2 to become? A positive 6 or a negative 6, because as long as we have one in there that's opposite the others, you can divvy it up how you wish. But let's go ahead and turn them into a positive 6 also. So what do we multiply this row by? And I should have multiplied by negative 2, right, on that second one? Is that correct? And then, okay. And then this one should be multiplied by negative 3. So we have a mission, and you're going to like the way this turns out. Again, it takes a little bit of time, but the process is super tidy, and there's a little bit less chaos on the board. So sorry, we're going to rewrite the whole system. You'll have to just deal with that. So I'm going to take the top equation, and I'm going to copy it down. I'm not doing a darn thing. Negative 2x minus 6y minus 4z equals negative 14. Now here we go. This is the good part. If I take the second equation now and I do what I said I would do, multiply everything in it by negative 2, what do I get? Nope. I get 2x plus 6y plus 12z. 54. Good. And then we're going to take the bottom row times negative 3. What do we get?
12 plus y plus
So minus 3z equals, good. So I'll give you a second to get caught up there. But the idea there is that there may be some collateral stuff, some bonuses along the way. You might have spotted a bonus. Some other bonus things might happen. But really what happened, and we brute forced it into happening, is that all of the numbers in this blue box are exactly now the way that we want them to be. And so I don't have to go off to the side and manipulate rows individually. I just brute force the whole system into looking nice. Good. Yeah. So at this point, I'm going to rename these now row 1, row 2, and row 3. As far as I'm concerned, the original system, I have no room for you in my life. This is my row 1, row 2, and row 3. Let's begin. What's our first row combo? Let's do it. R1 plus R2 with a little arrow. What are we going to get?
8 is 1.
Very good. And that's the bonus that can sometimes happen. It's like, I didn't mean for that to happen. I was trying to make the y's cancel, but the z's were like, hey, or the x's were like, hey, we'll come along for the ride. Cool. So I got 8z equals, how much is that? 40?
Yeah.
Good. And we have to do another row combination also. Remember, whatever you kill, you got to kill it twice. And there's only one other set of rows up here that will kill the y's. Who are they? 1 and 3. If you try 2 and 3, you see how they're both pluses right here? They won't work, right? So we have to focus on where is the cancellation doable, and it's doable from the very top to the very bottom. So row 1 added to row 3 is going to give us what? How many x's? Mm-hmm. Nice work. Good math. So there's our system. We did it. We killed the y's and we did it twice. Feel pretty good about that. We flexed on it. And now you see the bonus is in that top equation. We don't actually have to solve this like a normal system. The top equation is just screaming, solve me for God's sake. Look at this equation. I'll put a little bubble around it. Divide both sides by 8. What is z? Nice. And when that happens, you just got to thank the math gods and say, appreciate it. Thanks for the solid. So that means my final answer, I'll put it up here in the corner of the television, is going to be blank, blank, 5. Yellow per Gavin's request again. That'll be the thing. Yellow is the answer. Good? Now, where do I have to go? And well, first off, let me ask you this. Who are we having to find next? You have to find x next because of this equation. I'm going to put a gold box around it. You do not have enough information to go find y yet. To find y, you need both x and z, and I don't have them both, but I soon will. So I'm going to take that equation that's in the gold box, and I'm going to change his z into 5. What would that equation now say? Nice. So now I can come up here to the gold solution of awesomoniousness, and in place of x, I can put 3. And it's at this point now that you can storm the castle and go back and say, I'm coming in. I got my x, I got my z, y, your days are numbered. And so you get to pick from the 4 unique equations, 5 unique equations on the left. Which ones?
Can we do the original?
You can do the original, or you can do one of the modified. But this seems to be something that you like here. Is that correct, Brady? Yes, you may use any of them in existence. Original, modified, they're all in play. So our final objective is to solve for the third variable. And if I know 2 of the 3, I'm going to do a little erasing now. Sorry. And I'm going to take that gold equation and the one in the gold box over here. Should use a different color. And I'm going to change the numbers, put in the numbers that I can. Where it says negative 4x, what will it actually say? And where it says minus 2y, it will still say minus 2y. Where it says plus z, it'll say plus 5. And then again, I'm sorry if this kind of stuff vexes you, but just a negative 3. You're welcome. Again, just basic math on the left. If you combine your constants, negative 12 plus 5 is negative 7. Add the 7 over the other side, you get 4. So you get negative 2y equals positive 4. You get y equals negative 2. And the puzzle is complete. I have one more. Yeah. Sorry. Not sorry. We'll get to more paper. Ooh, boo-hoo. I hope we have time to finish this, but if we don't, well, that's okay. Last one. Negative x minus 6y plus 6z equals 25. Negative 4x minus 6y minus z equals 0. Negative 4x plus 2y plus 3z equals 16. All right, let's get in and get this bad boy started. Then if you understand everything that's happened so far, then you'll encounter nothing that's difficult. We're over the hard part. So Who looks the most delicious to us?
To multiply the bottom.
Yeah, so path of least resistance here is if I just take this row, bottom row times 3, then that's a win for all of us because then the y's will all be -6, -6, and +6. So to save a little bit of space in this case, since I don't have to rewrite the whole system, I'm going to show you a little trick. I can just take this bottom equation and watch what I'm going to do. I'm just going to multiply it by 3 and get -12x plus 6y plus 9z equals 48. And then just to kind of keep yourself straight here, you can take this equation and give it a little bit of light vandalism, just to remind yourself that he's temporarily out of play. So instead of rewriting the whole system this time, I thought, well, I've already got the top two. I'll just screw with the bottom one and call it good, right? Okay, and it's time. So let's do what we do. Who's going to be our first row combination? I agree. So let's do row 1 plus row 3. And what are we going to get?
13.
Negative 13x. How many y's? Of course, they cancel. How many z's? And then 25 plus 48 is 60, 73. Where does the next y murder come from? Row 2 and row 3. Very good. So row 2 plus row 3 will result in how many x's? How many y's? None, of course. How many z's? Yeah. And then equals 48. Remember what I said, and we're all human. I'm not speaking from on high, just as a guy that cares about you. We'll make mistakes, but we have to try really, really hard not to. Because these problems are annoying enough than to have to go back and trace mistakes. It sucks. So now we have a 2 by 2. And so when you look over here to the right, I'll put a little gold bracket around it. Clearly, nothing is auto elimination. Who looks easier to kill?
The bottom one.
You have to kill the x's or the z's. You have to solve the 2 by 2. I know. Who's easier to kill, the x's or the z's? Probably the z's. I can turn them both into 120. I don't know if you knew that or not, but let me show you a trick before we pack up. So yeah, definitely don't pack up yet. Okay, please. So I'm going to take the top equation. This is the old crisscross trick. I'm going to take the top equation and multiply it by -8. And then I'm going to take the bottom equation and multiply it by +15. You may not know what 8 times 15 is, and that's fine, but you sure know that if you take an 8 times a 15 and a 15 times an 8, they're going to equal the same thing, right?
So you just don't.
Say again?
So you just don't.
Right. Let's see, we have not much time. So let's pause right here and we'll finish this example. It'll take 3 minutes at the beginning of class, and then tomorrow's a nice solid work day for you, okay? Thank you for sitting through all of that. Say it again. It will be, yes.